Hey, what's going on, everybody? As I promised, I'm here to do a quick overview of spanning tree. This is going to be a little bit different approach. I'm going to try to fly into this lab blindly. I did do what I did do is I did pre-configure all the interfaces, the trunk links, and the port channels that needed to be configured. But as far as the spanning tree topology goes, I didn't look at any of the spanning tree as it currently is. We're going to run through based off of the rules of spanning tree on the designated port and the root port selection. And then also obviously we're going to have to do the root bridge selection, but just a quick overview. This video is not going to really be a full base theory video. It's going to be more of I guess you can call it a theory, but we're not going to go too much into a lot of the back end book knowledge on it, just a lot of the functionality. And that's what we're going to kind of focus on here, and just seeing if we can predict a spanning tree topology and control it the way that we want it to. We want the layer 2 traffic to be flowing. Spanning tree is just one of those topics that, unless you are constantly using it, which I don't know a lot of engineers who just work spanning tree issues all day long. Unless you're coming from a Metro East service provider, but even so, that's a semi-metro. Well, it's a semi-Ethernet environment. It's usually MPLS that's delivering that service. But I digress. We'll just, my whole point of saying that is because I'm currently studying for my CCIE. And, when I go back to some of my layer 2 topics, it's not that you don't know it. It's just sometimes, you get back to it and it's like, spanning tree. How did this go again? How did the root port go again? And, it's one of those things that, it's you don't use it in production, but on the Cisco exams, it will kill you, especially on the switch portions of the test. So we're just gonna say, like I said, we're just gonna run through a topology that I got configured in GNS3 using IOU 2. And you know what? There was actually something that I didn't do in all the configurations that we'll end up doing that I'm thinking about now. But so essentially, some terminology here. The root port is the interface facing the root. The designated port is the interface forwarding away from the root. So your designated ports, usually your root bridge has all designated ports because technically that is the port forwarding away from the root. If that makes sense. Your alternate port, which is the backup to the designated port. So essentially, if you have two designated ports going towards a root, when you go through the designated port selection, you'll never have two designated ports facing each other. So essentially one port would be designated and then one port would be the alternate based off the designated port selection. And then added to 802.1w, which is rapid spanning tree, is the backup port. And that is a backup to the root port. And that essentially happens if you have two uplinks to the root. And you tie on your root bridge. Essentially, you tie on these two selections here, right? Essentially, then you'll end up going by the lowest port ID, and the one with the highest port ID typically gets the backup port role. Alternated only going for the designated ports. Alright, so we'll look at the root bridge selection. So as we should know, the lowest bridge ID wins first, and usually the lowest bridge ID is a combination of the bridge priority and the MAC address, and by default it's 32768 on Cisco switches. Now if you have a tie on the bridge ID, typically then you'll end up going to the locust MAC address, and this kind of is 1 and 2 is kind of fledged into together. So if you have three switches that have the default priority of 32768, essentially that's the bridge priority piece of it, and of the ID. And essentially, if that is the same, it automatically looks at the MAC address portion of that bridge ID. So the root bridge selection is a little confusing because the bridge ID is essentially the MAC address, and so keep that in mind when we're deciding that, because if you have a tie on your bridge priorities, then it's obviously going to go based off of the MAC address. But if you have a say you have one set with the lower priority than the other switches, then it's going to go based off of that bridge ID's lower priority. So I say MAC address, and that's only in a sense of a tie where you have equal priorities, bridge priorities to the network. And then you got your port ID, which is your port priority and the port number combined together, and that'll be your steps for the root bridge selection. And then the designated port selection. What you want is, and another thinking about it too, I want to get back to the root port when we're talking about designated port selection. It's the interface with the lowest cost to the root. Interface, and I'll just go ahead and up that now because it is facing the root with the. But just because it's facing the root doesn't make it a root port, so that's something that I do need to, I should point out as well. So it's the interface with the lowest lowest cost to the root. And now going to the designated port selection, we have so we end up going to the designated, starting from the, I usually, because this portion you can do in sections. And you'll see what I mean once we start determining which ports need to be what. But essentially it's going to start, the person who gets the designated port is the one with the lowest cost of the root. And if there is a tie in the path cost, then the one with the lowest bridge ID. Once again, the bridge ID is that tie between the MAC address and the bridge priority. And if it fails, it goes to the lowest MAC. And if the lowest MAC fails, then it would go to the lowest port ID. And those are pretty much your selection. And one of the things that as you start going through this, you start actually appreciating expanding tree. And then if you get into multicast, it essentially works almost the same way. When you're dealing with rendezvous points, it pretty much works exactly the same way. In theory, not necessarily in operation, but in theory. So spanning tree does it is pretty cool. And once we start figuring out what ports need to go forwarding, what port needs to do root ports, which needs to be blocking ports, and then from there. So let's go ahead and take a look at the topology that we got designed here. I went ahead and, like I said, I grabbed the interface cost. I configured the port channels, the solid lines of port channels. Some of these connections have these dual lines, which is 2 uplinks to the switches. And right now, within the spanning tree topology, we'll just take it as a new network. Essentially, this is going to be, from what I designed it to be, this is your distribution network, and these are your access switches. And currently, if you leave it as is, what you're going to see is the one with the lowest bridge ID, who's going to end up becoming the root bridge for the segment. And you'll see all the traffic having to flow through that root bridge, and it's going to be ineffective because I didn't design it to have the redundant links to what would technically be the lowest bridge ID. And let me go ahead and update that as well. 32768 thoughts. Cool. So now that we got that updated, so there's a let's go ahead and start. We kind of went over the theory a lot. So first things first, let's figure out who is the root bridge for the segment, right? And we're like sort of looking at the combination of the bridge ID, which is the combination of the priority and the MAC address. And you can see the priorities are equal across the board because brand new switch implementation. We dropped 6 switches, plugged them all up, and we said, hey, let's spanning tree do its thing. Well, that's gonna kill us in this case, and I'll show you why. Switch 1 here, we'll see all the MAC addresses, you compare them, and looking at all the MACs, you'll notice that switch 1 happens to have the lowest MAC address. So he will end up becoming the root bridge for this entire segment, for whichever VLAN that we're going to focus on, right? So we'll call him, this is going to be the root. We'll label him root. All right? So first things first, what we're going to do is we have our ports here. We're going to go ahead and set up what ports need to go on the root, and he should have all designated ports, right? So we'll go ahead, designated port 1, designated port 2, and designated port 3, right? So we got all our designated ports. These are going to be the ports forwarding away from the root. Essentially designed to do what it's supposed to do. So your root bridge will always have designated ports, and those are forwarding. Good. Now, first things first, let's go ahead and start working on the designated port selection. The designated port selection for the non-root bridges. Now, like I said, you can tackle this. This network may look like it's a lot of interfaces to deal with, but you deal with this on a segment by segment basis, right? So let's start with switch 1 or switch 2. So for this segment here, what we're going to do is let's figure out the different paths that we have and add them up to figure out what the cost to the root is. And just for ease of configuration, ease of math and all that stuff, I'm just going to pull up my handy calculator. I could do it in my head, but I'm not going to do that. So we got our handy calculator here that's going to assist us in doing the math that we need to make sure that we're calculating the root cost correctly. Right. So starting on switch 2, right, we want to figure out which path is the lowest cost to the root bridge. So we start here. We got a cost of 100, which is good, right? So far, only 100. We go this route. It's 100 plus 56, so that's 156. That's definitely not a low cost. This way, we go in 1 to 56 and then 100, so it's 156 going that way. That's not going to help. And this one we got 100, 200, 256. And that's definitely not the lowest cost. So we already figured out where our lowest path is, right? So our root port goes here, right? And you know what? First thing, we're going to first figure out the root ports and all the switches. I find that for myself to be a lot easier before working on the designated ports. So switch 2, we got his root port, right? Switch 3. Switch 3, we'll figure out his path. So we got 100, 200. So it's 200 to get to the root. His is 100, 156 to get to the root. Now, where is his root port going to go? Right. So we got 100, and then we got these two paths, 200, 100, 200, 100, 200, right? So we already see the best path to get over to the network is through this link here, the 156 link. Right? So going through switch 6. So we'll go ahead and make that his root port. Perfect. Now, switch 4. Same thing. We're going to figure out what the cost of the root is. 100, 200, 300. Then you got 100 here, 156. 100 here, 156. Ooh. And then 100, 200. Perfecto. So, looking at this topology, we're seeing that we have... you know what? Okay, so the only thing that's going to suck, I didn't label the port IDs in this case, and this is where the port ID is going to come into play. So we got the lowest cost of the bridges here, right? But that's going to be a tie coming from the same bridge, right? Coming to the same bridge uplinks. Because it's 100 this way, 56, 100 this way, 56. This would be going based off of the lowest advertised port number. So we'll say this is Ethernet 01 and Ethernet 00. So if this was, like we're saying, this is a tie, Ethernet 01, Ethernet 00 would win because it's the lowest advertised port. So that should be your root port there. Perfect. And now we'll go to, we'll just call that Ethernet 01, just so it's a little cleaner. Alright, so switch 5. Same thing. We start figuring out the path to the root. We got 100 here. We got 56, 100, 156. You got 100, 200, 300. Same thing, 100, 200, 300. Then you got 100, 200, 300, 400. Now, what do you see here? That looks a little crazy. We have a nice fat port channel trunk, right? That's sitting at 156 cost of the root and a little 10 megabit uplink to that same switch at a cost of 100. Well, guess who's going to get the root port? This guy. Because that is the interface with the lowest cost going to the root. So he will get the root port. Perfect. Oh, and then we got one more. And then same thing here. We got 56, 100, 200, 100, 200, 300. And so essentially we already see the root port is going to be this port here, right? Now, it looks a little mumble jumble now, and this is where the root port, the designated port selection comes into play, right? So what we're going to do first, actually, we're going to stop right here, and then I'm going to pick up from here in the designated port selection. YouTube video limits, can't break it, so be right back with you guys.